Hey everyone, and welcome back to Blackboard AI. Today, we are tackling a performance puzzle that often confuses developers. How does NGINX handle millions of requests with seemingly just one process? Well, here is the critical point. That one process you often see is not the only process. And it certainly is not doing all the client request work itself. The core of NGINX's power lies in its architecture. NGINX uses a master worker process model. There is indeed a single master process. Its main responsibilities are administrative. These are the worker processes. These are the processes that actually do the heavy lifting, handling the client connections, reading requests, processing them, and sending back responses. Typically, you run one or more worker processes, often configured to match the number of CPU cores. Okay, so we have multiple worker processes. But how can even a few worker processes handle millions of concurrent connections efficiently? This is where the magic truly happens, and it is not about having a dedicated process or thread for each connection. The key is asynchronous, non-blocking I/O and the event loop. Think about the old, traditional way many servers handled connections, like Apache's perfork module. For each incoming connection, a process or thread is assigned. This process or thread then blocks, meaning it just waits. While data is being read from the client, or while waiting for a response from a backend server. It sits idle, holding onto system resources, until that specific operation completes. This works for a small number of connections, but imagine millions. NGINX uses a different approach. A worker process does not dedicate itself to a single connection until it is finished. Instead, when a worker process receives a connection, it registers its interest in certain events. How does the worker know when something is ready? Through the event loop. Each worker process runs an event loop. This loop continuously checks with the operating system, for which connections have new events ready. When an event occurs, the worker process handles it briefly, rapidly switching between them only when there is actual work to be done for that connection. This architecture is what allows NGINX worker processes to be incredibly efficient. So next time you see NGINX handling massive traffic, remember: 1. It is not just one process, it is a master plus multiple worker processes. 2. The master manages, the workers handle connections. 3. The key is the worker's event-driven model, non-blocking I/O and the event loop. That is how NGINX achieves its blazing fast performance and scalability. I hope this cleared up the mystery of NGINX's single process power. If you learned something new, please give this video a thumbs up. And make sure you are subscribed to Blackboard AI for more deep dives into tech concepts explained simply. Thanks for watching, and I will see you in the next video.